ISRO made history with the successful launch of Chandrayaan-3, and now, they are back at it again with the launch of Aditya L1. This 44.4-meter tall PSLV rocket took off majestically from the eastern coast of India, marking the beginning of an exciting journey. Aditya L1 is the first ever Indian space-based observatory dedicated to studying the Sun. If you want to know which are the other country who are also determined to conduct a study on Sun and what are their mission, please let us know in comments. We will make a detailed video. Aditya L1 isn't just heading straight for the Sun, it's taking a unique path. After traveling approximately 1.5 million kilometers from Earth over 125 days, it will be placed in a halo orbit around a special point called Lagrangian point L1, which is the closest point to the Sun. But what's so special about L1? Well, it's one of 5 points in space where objects tend to stay in a stable position with minimal fuel consumption. Why should we explore the Sun? What is L1? Exploring the Sun is crucial because disturbances from the Sun, such as solar flares, coronal mass ejections, and solar winds directed towards Earth, can have adverse effects on space weather. These disturbances can disrupt electronic systems, cause power outages, damage satellites, and pose risks to astronauts in space. Therefore, understanding the Sun's behavior and monitoring these phenomena is of paramount importance for space science and technology. Let's delve into the layers of the Sun first. The Sun is a massive celestial body at the center of our solar system, and it is essential for life on Earth. It consists of several distinct layers, divided into inner and outer layers, contributing to its energy production and dynamic behavior. Let's know more about the Sun's layers and structure. The Sun is a gigantic ball of extremely hot, ionized gas, known as plasma, and it shines due to nuclear fusion reactions in its core. It has a vast size, with a diameter capable of holding approximately 109 Earths side by side and a volume equivalent to around 1.3 million Earths. Outer layer. 1. Photosphere, the lowest and observable layer of the Sun's surface, characterized by granulation and sunspots. It has temperatures ranging from about 6,500 K at the bottom to 4,000 K at the top. 2. Chromosphere, situated between 250 and 1,300 miles above the photosphere, the chromosphere has temperatures ranging from 4,000 K at its base to 8,000 K at its apex. 3. Transition region, an extremely thin layer, about 60 miles wide, lying between the chromosphere and the corona. It exhibits a rapid increase in temperature from 8,000 K to 500,000 K. For corona, the topmost layer of the Sun, extending beyond 1,300 miles above the photosphere, with temperatures ranging from 500,000 to 1 million K. It is visible during a total solar eclipse using a coronagraph telescope. Inner layer. 1. Core, the central region of the Sun where thermonuclear processes occur at incredibly high temperatures of about 15 million degrees Celsius. These processes convert hydrogen into helium, releasing energy in the form of light and heat. 2. Radiative zone, located between the core and the convective zone. This region constitutes around 70% of the Sun's radius. Electromagnetic radiation from the core takes over 170,000 years to travel through this zone, as photons repeatedly scatter before reaching the surface. Convection zone, the outermost layer of the Sun's interior, starting from a depth of about 200,000 kilometers and reaching the surface. It features intense convection currents driven by heated gas, carrying energy towards the Sun's surface. Now let's get back to L1 Tichy Lagrange point. What is L1? Lagrange points are special positions in space where the gravitational forces of two large masses, such as the Sun and Earth, balance the centripetal force required for a smaller object to orbit with them in a stable pattern. There are 5 Lagrange points in this system, named after mathematician Joseph Louis Lagrange: L1, L2, L3, L4, and L5. Among these Lagrange points, L1, L2, and L3 are considered stable, while L4 and L5 are also stable but located much farther from Earth compared to L1. ISRO chose L1 because it offers a continuous and unobstructed view of the Sun, making it an ideal location for the Aditya L1 mission. However, it's important to note that L1 is unstable on a relatively short time scale of about 23 days, which means that satellites placed there, like Aditya L1, must regularly make adjustments to maintain their position at this point. So why are they sending Aditya L1? What's the mission? The Aditya L1 mission aims to address several key objectives, including investigating coronal mass ejections, which involve the expulsion of magnetic fields and plasma from the Sun's corona. Analyzing the magnetic field of the Sun's corona, a significant driver of space weather phenomena. Studying the chromosphere and corona, the upper layers of the Sun's atmosphere, to gain insights into their behavior. Enhancing our understanding of the acceleration of particles from the Sun, which leads to the formation of solar wind. Exploring the mystery of why the Sun's atmosphere is hotter than its surface. In summary, Aditya L1's mission objectives revolve around advancing our understanding of the Sun's dynamics and their impact on space weather, ultimately helping us mitigate potential disruptions to Earth's electronic systems and technology-dependent infrastructure. Difference between Aditya L1 and other missions. India is the third country to have a mission at L1. It is multi-wavelength, multi-instrument and multi-direction. You don't have such a satellite existing in L1 so far, said Anil Bharadwaj, Director of Physical Research Laboratory, while speaking after the launch. What is multi-wavelength, multi-instrument and multi-direction? Multi-wavelength and multi-instrument. Unlike previous missions, Aditya L1 is a multi-wavelength mission, meaning it observes the Sun in various spectral bands, including X-ray, ultraviolet, and optical. Additionally, it carries multiple instruments designed to study different aspects of the Sun, allowing for a comprehensive understanding of solar phenomena. Multidirectional, Aditya L1 is capable of observing the Sun from multiple angles and directions, providing a broader perspective on solar activities and their effects on space weather. This multidirectional capability enhances its ability to study various solar phenomena in detail. There are total 7 payloads. Remote sensing payloads. 1 visible emission line coronagraph, in short VLC, capable of imaging and spectroscopy of the solar corona. 2 solar ultraviolet imaging telescope, in short SUIT, focuses on imaging the photosphere and chromosphere using narrow and broadband filters. 3 solar low-energy X-ray spectrometer, in short SOLEXS, designed for soft X-ray spectroscopy, enabling observations of the Sun as a star. For high-energy L1 orbiting X-ray spectrometer, in short HEL1OS, equipped for hard X-ray spectroscopy, facilitating Sun as a star observations. In situ payloads. 5. Aditya Solar Wind Particle Experiment, in short ASPEX, analyzes solar wind and solar particles, including protons and heavier ions, with directional capabilities. 6. Plasma Analyzer Package for Aditya, in short PUPA, studies solar wind and solar particles, including electrons and heavier ions, with directional measurements. 7. Advanced Triaxial High-Resolution Digital Magnetometers, provides in situ magnetic field measurements in 3 dimensions BX, BY, and BZ. The mission's primary science objectives encompass the study of solar upper atmospheric dynamics, chromospheric and coronal heating, initiation of coronal mass ejections, and flares. Aditya L1 also aims to observe the in-situ particle and plasma environment, understand the physics of the solar corona and its heating mechanisms, and identify the sequence of processes leading to solar eruptive events. Additionally, it will investigate magnetic field topology and solar wind dynamics, contributing to our understanding of space weather drivers. For more informative videos, like, share and subscribe.